All right, 9.4 is all about choosing appropriate displays of data, and we're also going to talk about misleading representations of data in the second half of this lesson. Okay, so we have several types of displays of data. We have pictograph, which the first part of this word is picto, so you can think of picture. You show a set of data using pictures. A bar graph is specific categories. A circle graph is part of a whole. A line graph is over time. That's important to remember, over time. A histogram shows frequencies of data values in intervals of the same size. Stem and leaf plot, this is your stem and these are your leaves. So this would be 10, 12, 13, 16, 21, 21, 25, and so on. A box and whisker plot shows the variability of data by using quartiles. So this is your minimum, your lower quartile, your median, your upper quartile, and your maximum. Some of you might not be as familiar with this, but I can do an example in class tomorrow. A dot plot shows how many times each thing happens. So this happens once, this happens twice, this happens 3 times, this happens no times. And scatter plots shows the relationships between 2 sets of data by using ordered pairs. This is what we've been doing this chapter. So example 1, we need to choose an appropriate data display and explain why. So this is the number of students in marching band each year. And because of this keyword each year, I'm going to use a line graph because there is a change over time. A comparison of people's shoe size and their heights. Well, this should be kind of easy because we just did this. So this is a scatter plot because you can write these as ordered pairs. And then you just plot the points like so. So on your own, choose an appropriate display for 1 and 2, and then hit play and see if you got the right answer. All right, this whole divided into age group thing, this is also called frequency. This can be something as a frequency of ages. So if we're talking about frequencies, we want a histogram because it shows frequency of ages in intervals of the same size. So it could be the population divided into age groups. So it can be, I don't know, 0 to 10, 10 to 20, or 11 to 20. You get the point. Okay, those would be the age groups. The percents of students in your school who play basketball, football, soccer, or lacrosse. Now, I can see this in 2 ways. I can see this as a bar graph because you are comparing something, and that's what a bar graph this is the specific categories. So your specific categories are basketball, football, soccer, or lacrosse. I could also see a circle graph here because it says the percents, okay? So you could easily divide this up into the percents of people who play each of these sports. So either one of those examples would be fine. All right, so example 2. So now we're talking about identifying an appropriate data display. So you record the number of hits for your school's new website for 5 months. Tell whether the data is appropriate for representing how the number of hits changed, during the 5 months. So this is my data over here, and this is how I interpret it. So this bar graph shows how many hits were each month. So I would say, yes, this is appropriate. Because it shows hits per month. And that's what I wanted to show. B and C are on right below it. So this is a histogram. So from 0 to 399, I had a frequency of 2 times. Same thing from 4 to 799, and 8 to 1199, I only had to happen once. This would not be appropriate because it does not show data over time. There's no way for me to see go back. There's no way for me to see how it happened between August, September, October, November, and December. So no change over time shown. On the other hand, websites hits August through December and have the number of hits. This is an appropriate display because it shows time. Shows change over time. All right, last part. We need to identify misleading displays in data. So which line graph out of the two is misleading? I would say that anytime you see what's called a break, anytime you see a break in the graph, it is misleading. So the graph on the left is misleading. This one has an accurate representation. You know that there's no money between 0 and $8 billion between 2005 and 2011. This one, it looks like the graph starts a lot lower, and that's because of the break. So is it okay to use a break in a graph? Yes, but it can also be misleading to the reader. So which graph is misleading? The one on the left. Example 4, analyzing this misleading data display. So a volunteer concludes that the number of cans of food and boxes of foods donated were about the same. Is this accurate? Okay, so this is a pictogram because we're using pictures. Okay, and the issue with this pictogram, so they're saying a can equals 20 cans, a box equals 20 boxes, and a bottle equals 20 bottles. So I would say that this is 20, 40, 50, 20, 40, 60, 80, 100, 120. And this is 2, 6, 7, 8, 9, 10, 11 times 20, which 220. So this is misleading because even though if you're just looking at this graph and you don't look at the key, the canned food and the box food look like they were very, very close to each other when in actuality they were over 100, or excuse me, exactly 100 apart. And the reason this is misleading is because the size of the pictures are not the same. So, size of the pictures are not the same. Therefore, it is misleading. All right, on these two on your own, explain why these graphs below are misleading. Hit pause, try them on your own, and when you are finished, hit play and check your answers. All right, so the on your own, the first one is misleading because there's a break in the graph and also the tickets are different sizes. And the second one, this is misleading because the width of these bars are not the same size, so it appears as if the profit appears greater. So that's it for this lesson. See you tomorrow.